Hello. Hi. Wow. Been a long time since I recorded anything on this, so it's going to look weird because I'm not going to look exactly at the camera all the time because I'm still looking at the screen. All right, so this is about writing polynomials. Okay. Special request, by the way. Okay. So writing polynomials. Now, when we write a polynomial, or when we are asked to write a polynomial, you're going to be given the roots of that polynomial. Let's go, camera. You're going to be given the roots of that polynomial. Now, this particular polynomial has 3 roots, okay, and they're all real, right? So we know through the fundamental theorem of algebra that this has to be something x to the 3rd power, right? Because we've got 3 roots. Now, so we're going to work backwards this whole way. Roots have to go to factors, and then we can multiply the factors together, like foiling. But first, we got to find the factors. Now, remember, if these are the roots, this one is relatively simple because I have to find x minus or plus something. If positive 1 is a root, that means x minus 1 is the factor. Right? I'm just working backwards. 3 is similar to this, where I'll have x minus 3 as a factor. Now, negative 3 over 5. Yeah, we would have x minus a negative 3 over 5. But try to turn this into a 2-step equation, backwards style, and you'll get the hang of it as we go. That's going to end up being 5x plus 3. Because if I figure something has to equal negative 3 over 5, well, first, I have to multiply the 5 back to the other side, and then I have to add 3. So, for example, I know that sum x equals negative 3 over 5. But if I'm trying to make 0 be on this side, first we multiply by 5 on both sides, and then we add 3 on both sides. And voila, we have 5x plus 3. Here are our factors from our roots. And now, to get to the polynomial, I'm just going to FOIL or multiply out. So we'll take the first 2 together. We'll do x squared minus 3x minus 1x plus 3. Combine like terms, so x squared minus 4x plus 3. Now we're going to bring down the other binomial, and we'll multiply that out. Now, it's not FOIL so much because we have a trinomial and a binomial, but we're just going to take turns multiplying. This is the part where we have to be really, 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 really slow and careful. Okay? Just take it slow. I'm going to take it really slow. If it helps you to cross things out, do that. I just like looking at it and making sure I've got my sets. Now remember, we should have 6 terms when this is all done with, okay? Whew. 1, 2, 3, 4, 5, 6, right? Because I'm multiplying a 3 by a 2. Okay, now we'll combine like terms, and we should end up with our final result. 5x to the 3rd, there is no other thirds. A square and a square. Single, single, constant. Is that our answer? And it sure is. There's the polynomial from the roots. Okay, hopefully that's clear. Now let's do one that has complex roots or imaginary roots. It's the same process. It's just a little bit uglier. All right. We'll do an easy one for the sake of time. Say I gave you roots of 1 and 1 minus 3i. Okay, well, there's a problem here. I've only given you 2 roots. But we know that complex or imaginary roots must come in pairs. So we need to have the complex conjugate of 1 minus 3i, which is 1 plus 3i. Because remember, the fundamental theorem of algebra, all those fun theorems we know now, that complex or imaginary roots have to come in pairs. They can't just be by themselves. Okay. So now I have 3 roots. 2 imaginary, 1 real. Same process. We're going to factor this, or get it to factors. So if 1 is a root, x minus 1 is a factor. If 1 minus 3i is a root, we're still doing x minus, but in the parentheses, we're going to do 1 minus 3i. So it's like a double parenthesis, a parenthesis inside. And then we'll do the same thing, x minus the quantity of 1 plus 3i. Now, why do we do that? Well, we do that to kind of separate things and help us distribute properly. X minus 1 is x minus 1, easy. This is going to turn out to be x minus 1 plus 3i. And as you can imagine, this one will be a little different, where it'll say x minus 1 minus 3i. Okay? Now, for this particular one, I would multiply the x minus 1 last. I would multiply the two conjugates together because the i's are going to be a little messy. Now I'm doing a 3 times a 3, so I should get 9 results here. So let's just move this to the end. And we'll go from there. You can do 3ix. I like to put the I at the end, though. So if that makes you a little confused, it's okay. I just like to put the imaginary part on the very end. Okay? So I multiply a 3 by a 3, and I got 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Now, we'll combine like terms. Some things will cancel out here. And then we got to deal with that I squared thing. All right. So x squared stays. Minus 1x. Those are the only two. Right. So we got a minus 2x here. I've got a negative 3xi and a positive 3xi. Nice. Those are nasty. Now they're gone. Okay. The plus 1 will hang out with for a second. It's going to go on the end. I've got a plus 3i and a minus 3i. Huh. That's why we do complex conjugates. That's why we do conjugates. So that nonsense cancels out. Now we have a negative 9i squared. Well, if we're going to just bring all this, the rest of this stuff down, it'll be easier to look at. Okay. Well, I squared is negative 1. So this says negative 9 times negative 1, or just 9, which is plus 1 plus 9. So this is x squared minus 2x plus 10. Now we can bring back the x minus 1. And again, we're multiplying a trinomial and a binomial, so I have 6 terms. Combine like terms, so I have an x to the third. I have a negative 1x and a negative 2x, so negative 3x squared. And plus 12x minus 10. I'm looking for the answer. Yep. There we have it. Again, this is a tedious process. This is an 8.5-minute video for 2 problems because look at all this junk. Okay. Take your time with it. Obviously, the key is to get the factor set. If you get the factor set, you should be good to go. Okay? Hope you liked the video. See you later.